Last week we talked about the P2P structure architecture. We look at three architectures from the very beginning. The centralized architecture, where we have a centralized directory server with the directory of all resources. However, the problem is that it won't scale well if you have such a centralized structure. And then we look at the decentralized but unstructured architecture, where you would rely on frauding. You rely on frauding to fraud the queries. Okay. However, the frauding needs to be limited in scale, in the number of hops that you can fraud. So again, you might end up couldn't find the resources you need, but there is such a resource in the network, but you couldn't find it because your frauding is limited. If the frauding is unlimited, then it creates another problem where where there'll be too many frauding messages. So instead, there's another improvement to improve this decentralized unstructured P2P into a hierarchy, where on the at a top level, at a higher level of the hierarchy, it's totally decentralized and rely on limited scope frauding. However, in the lower layer in the hierarchy, you have a centralized approach, centralized directory server. So you, at a lower level, regional level, local level, at a local region, you have a centralized directory server. But between the clusters, it's decentralized and rely on frauding, limited scope frauding. And this hierarchy seems to scale better, but you need to rely on the so-called super peers. The super peer needs to be there all the time. Okay. If so there must be a mechanism to elect the super peers that will serve as a centralized directory server in that region. Okay, so the advantage, fully distributed and reliable photo and no single point of failure. But the disadvantage is that you need super peers, which might be overloaded or attacked. And still, at the top level, it relies on frauding, limited scope frauding. So you still have the problem of failing to find content that is actually there in the system. And still, in many cases, you couldn't find your resource in your region, so you need to rely on the super peer doing frauding to search the resources for you. So there'll be excessive query traffic between the super peers. So there's a new architecture called decentralized but better structure. The structure here means that the way you praise the resources, is structured, and the structure is defined by the hash function. So we are trying to build a structure in a decentralized architecture by hashing the content or the resource into an address space. And in the meantime, we also hash all the peers into all the peers in the P2P network into the same address space. So as I mentioned last time during the final minutes, we mentioned that you map the peers and also the resources into the same address space. Okay, and if for example we are all peers in the P2P network, in the same P2P network, so we hash every one of us into an address space with a number, and then for any file we want to share, we also hash into the same address space. So if I hash the file to 31, okay, to an address with an address of 31, then the peer, which is also hashed to 31, should be the one who is in charge to keep the directory. So I would if I'm holding the file, I hash the file to 31, then I should send a registration message to the peer 31. For example, you are peer 31 because you hash your address to 31. So I send a registration message to you. Okay, and the other guy who is looking for the file, he does hash on the file on the resource, and he also got a number 31. So he would ask you who has this resource. Okay, then you will reply to him because I have registered to you already. So if I'm the resource provider and he is the resource consumer, and then you become the resource registrator, okay, for that particular resource. So I would register to you, and he would query you, and you reply to him that this guy has the file he needs. Okay, so that's the idea of structuring, having a distributed directory service. So the directory now is fully distributed. Every one of us could be a directory server for several resources, as long as those resources they hash to us. To me. If those resources hash to me have a hash value of my ID, for example, mine is 42. And then because I hash myself to 42, then I would serve as the directory server for all the resources that have the hash value of 42. Okay, so anyone who have those resources with a hash value of 42 would send registration message to me, and I would serve as the directory server for those resources. And I would know who have those resources. Okay, so it's a distributed directory service by such a hash function. Of course, the hash function we use should be the same. Otherwise, we wouldn't have the consistent view. So in a way that we structure the resources address space, and also structure the peer address space into the same space. Okay, is that clear? The way this decentralized but structured architecture works. Okay. So this just repeat what I just said. So we could skip that. However, there's a problem. There's a problem where you hash the node into an address space, a linear space, address space. However, not all the hash value or the address have the peers. I mean, perhaps the peers, some of the number do not actually have the peers. So if I hash to a value here, nobody here, so I would look for other peers who are actually there. So this table called finger table of approach called code try to solve this problem when we hash into a linear hash space, but not all the numbers have the actual peers. Some might be, I might not have peers with that numbers. Then then I would need to find nearby. So if I hash to this address, then I would address 38, but there's no peer with this address. Then I would look for the next available one, and I would check here whether he has this node has the resource I need, which is the finger table. Okay, so next we look at the. So I would say that P2P is among the applications we have covered so far from the DNS to right now the P2P. Even though there are still research going on for DNS or research going on for www, I would say that P2P is the most active one, the most active research area among the application layer. The reason is because consider this. I think I have similar argument last week that before P2P, every one of us see just servers, and we put the resources on servers, and only the resources on server are visible. The resources on clients are not visible. But with P2P, we don't need to post resources on server to become visible. Our resources are residing on the client could be visible too. Okay. However, to enable the resources on the client to become visible is a difficult job. For the resources on the server to become visible, we rely on what? We rely on what? The search engines, right? Because the search engine crawl the resources on the servers periodically. For example, the Google search engine will visit your website periodically. How often depends on how many servers it has. Okay, but it will visit your website periodically. Maybe a few days, maybe a few weeks, every few weeks. Then your content will be searched and indexed in the search engine, so that whenever someone wants to find the resources you put on particular server, it could be query on any search engines, and the search engine will reply the pages that match the keyword you issue in the query. Okay, so that's the way we find resources nowadays, but that's the mainstream now. But another stream by P2P is that you put your resources on your own computer. You don't put it on the server, and you want your resources to become visible. And now the state of the art is structured but decentralized but structured P2P network. And still, you have the concept of this P2P network. Within this P2P network, you form an addressing space for peers and also for resources. but you don't you don't. It's a boundary. It's not the entire internet. It's only limited to this P2P network. For example, every P2P application then form a community. Within the community, you can search the resources, and the community might not be big enough, or might be big enough, but still there's another community. For example, you have Facebook as a P2P network, but if your friend might be on LinkedIn, which is another community network. So if he is on LinkedIn, but not on Facebook, but you are on Facebook, then you won't be able to see each other, because that's a boundary. That's two communities, and those two communities, they don't talk with each other, so they are separate. So you might ask a question in the Facebook community, but that question is not visible through LinkedIn, and some guy in LinkedIn might be able to answer your question, might have the resource you need, but you couldn't reach. Okay, so right now the P2P still each P2P network then form a community, and the community could be small or large, and if it's large, then you got problems of scalability issues. Okay, so that's the interesting part of P2P research. Okay, some performance issue of P2P application, including free writing. It means that some people are not sharing. On the average, 85 of the participants are not sharing resources. They want to share others' resources, but they don't want to share their own resource. They don't provide resource to be shared, but they want to share somebody else's resource. These are free riders. So there must be solution for that, and the solution is providing some incentive. For example, if you share a resource, then you have better credit. You accumulate your credit, and when you have higher credit, you can have the priority to download the file. Okay. Okay. Flash cloud. That's when you have a hot content or new content, a new content which is hot, just released. Then there'll be a flash cloud that would congest the P2P network. Topology awareness. That's when a nearby in the P2P network, a neighbor in the P2P network might be far away. Okay, it's not probably in your subnet, probably not in your domain. Could be somewhere, maybe 10 hubs, 10 router hubs away. So a neighbor in the P2P network might be far away, and you need to be aware of this. Otherwise, you think that is the neighbor nearby, and you try to get the resource from that peer. It might take a long time because the round trip time is long. So in deciding where to get where to download the resource, you need to be topology aware. NAT traversal is another problem where both peers reside behind NAT. When both peers reside behind NAT, then it usually it will involve the hole punching problem, whether you can penetrate the NAT from either direction. You usually would need a third party which has a public IP address, another third party which has public IP address. to help the traversal. Churn is another issue. That the P2P, the membership in the P2P network is not stable. It's very dynamic. Could be very dynamic. Peers might join and leave anytime. So the P2P network, then the topology or the structure, even though you have hash function, the structure is not stable because they come and go. So that's the problem, the issue of churn. Security, it becomes the paradise for hackers to release the Trojan horse backdoors program. Okay, I could have a content with a very fancy name, with a very interesting name, or with a content with a name that that everyone want the content, either a game or a song or something else, and I release it through P2P, and you search and find, and then download, and then pray. Okay, once you pray, once you run or pray the content, the resource, then you got a backdoor, you got Trojan horse in your computer. Okay, and that Trojan horse might reside silently and stay unnoticed for quite a long time. So that's the problem of the security problem of P2P. And copyright infringement, where you have the well, it's again another paradise for exchanging copyrighted materials for free. So that's a problem. There are some solutions, but not total, but not full solutions. For example, the free writing in BitTorrent, they have a incentives mechanism called a tit for tat. Okay, if you have share more, you can get more quickly. So the solution seems to work fine. Flash Crowd, for new content, the solution is caching or duplicate popular objects. So it's not a big problem. The solution works okay. Topology awareness, you need to be aware of the round trip time. So it seems not a big problem. NAT traversal, in most cases, it's solved by the relay peers or the super peer that have a public IP address. So it's but again, if you continue to rely, if you always rely on the third party, a relay peer, then you might create triangle routing. You would not have direct connection. It's through triangle. So if you are two peers are behind NAT, and when these two peers want to talk with each other, they need to go through the third party, which is probably IP address. Then you have the problem of triangle routing. And so it's okay if you do that initially, but later on you want to talk to each other directly. The connection should be direct instead of through the third party. So NAT traversal, so when they evaluate how good the NAT traversal is, they usually evaluate in terms of the direct connection ratio, the % of direct connection among all connections. What is the percentage of connection that can have direct connection without going through the third party? That is still an issue. Um, and 2 years ago, I was doing that and published some papers last year. Okay, and shown, as I said, the common goal. So it's not a stable P2P network. And the solution is that you want to avoid a rigid structure. You want to have a more flexible structure instead of very rigid structure. And how? You maintain a list of potential neighbors for quick and dynamic neighbor replacement. So, so because you need to have you need to know your neighbors, but you also need to know more neighbors, so that if one of them is gone, then you still have the other neighbors. So that's the flexibility. Security. That's you want to protect the content from being replaced with a version with Trojan horse. Then what you do is that you want to protect the content with the message digest, such as MD5. We will look at that in chapter 8. It's an authentication mechanism by hashing. You hash a message. You hash a message through a value, and then you store the hashed value securely. So if the content of the resource has been modified, and you do hash again, it would hash to another value which will be different from the previous hash value. So then, so if the hash value is different from the previous hash value, then you know that the content has been modified. Okay, and that's done in BitTorrent. So the original author or original content provider would provide not just the content but also the hash value. Okay. So that seems to work okay, but it doesn't solve a problem. If I'm the original content provider, but I'm malicious, I provide a malicious content, and I do the hash value by myself. So then I release both of them. Then the content itself is already malicious, and you do the hash again, the value will be correct, but it's still malicious. So if the content provider is a hacker, then this solution won't solve the problem. You still have the problem. So there are some other solutions, for example, the reputation, peer reputation, object reputation, but they don't seem to work well. Otherwise, we wouldn't see so many P2P malicious content. I mean, so many malicious content running through P2P. They propagate through P2P. So so this is not well solved so far. Copyright infringement not solved either. It's still a paradigm, even though Napster, the centralized structure, the centralized directory server, Napster was closed. You still exchange a lot of copyrighted content on many P2P networks. So it's not well solved, and and some content provider, for example, the movie, the music publishers, they try to use some mechanism like digital right management, DRM, digital right management, but it doesn't seem to work well. Okay, the case study and open source implementation for this section is on BitTorrent, which is a a P2P community. It's not just the program, but it also forms a community, just like Skype, just like Facebook. Okay, they all form separate communities. And BitTorrent has a tit-for-tat mechanism, incentive mechanism to encourage the user, the peers to provide content. And it is a structure. It used the structure, decentralized but structured architecture with the it also try to distribute the different roles. For example, the source, the content provider, the downloading peer, the tracker, the seeder. They all have separate roles to play. And first of all, you need to if you are a content provider, you need to register your content, and then a downloading peer will get the code .torrent to get to know the metadata of the content. So .torrent is the metadata of the content describing the content. Okay, and then the downloading peer might get the file in several pieces and chunks. So because a file could be when it was designed, BitTorrent was designed to share large file, and those large files are mostly video files, which are quite large, usually several gigabytes or more. So in order to share such a large content, you want to break the entire file into pieces, and then each piece will be divided into chunks, and then and as a downloading peer, you might get different pieces or chunks from different peers. Okay. So they try to break down a large resource into small pieces, and then distribute it into the P2P network, and the way it is distributed is according to the hash function. I mean hash value, just like what we have mentioned, the decentralized structure decentralized structure architecture. So they distributed the pieces and the chunks in distributed directory, and the peer could grab the content from different from other different peers, but they all need to get a directory first. So it's a hybrid architecture where the tracker plays the role of a local central directory server for file, but decentralized in a way that a peer discover which piece to download from which other peer in a distributed manner. And there's a new development in recent years that they decentralize the tracker, decentralize the tracker. So you have a distributed tracker based on distributed hash table. Then you have the issue of piece selection, because each file has been divided into pieces. And then for each piece, you need to decide where to get the piece. So there are several policies from random to realist first. Okay. Piece selection and so peer selection. That where, so so which piece you want to download, and from whom, from which peer. So all these need to be selected. They have some mechanism, design several mechanisms for the program to select. There are many BT client programs, and all of them are open source. And these three are the most common, popular ones. And in the open source implementation, the book cover mostly on the peer and piece selection, how they implement the piece and peer selections. And I think I'll leave it to you for further reading on the peer and piece selection.